Hey there, so as we know, the past couple of weeks we've been doing solar cookers. There are three basic types of solar cookers. There's box cookers, panel cookers, and parabolic cookers. A cooker is basically any type of system that can harness the sun's energy and use it in a constructive way. What we're focused on is passive solar as opposed to active solar. Active solar is more of the power cells that take the sun's energy and convert it into electricity, which can run, anything run on electricity. We're taking solar cookers and just using the heat that comes through the radiative energy. So there's obviously these reflective devices that are much better than things we can create here. They cost a lot more, they take more exact measurements, and they need to be tracked by the sun if they're parabolic. Then we have things like the ones we made. They're pretty simple. That I chose to do the box cooker. So when we were building it, I just found everything around my house: cardboard boxes, aluminum foil, plastic bags. I didn't have a cup that would really work, so I ended up using a poster tube and a sandwich bag, and that worked pretty well. I just filled the sandwich bag full of water, put it in the tube, sealed it off with the cap that came with it. This is some of the materials before I made my cooker. So during construction, I was distracted because I was in the zone of making solar ovens and watching a football game. So I blamed the Broncos for not having any pictures of it. However, I will go into detail of my construction using pictures of the same things that I used, but a little bit more of a cartoon. So in the construction, took a basic cardboard box, and to that I added aluminum foil. The aluminum foil was the cheapest choice for me on a reflective object that we could use to concentrate the sun's heat. I put it on the flaps, and then I actually had another couple pieces of cardboard laying around that I was able to cover in aluminum foil as well and put down into the box. On the flat plane on top of the box, I put saran wrap. This it functions to intensify the solar energy as well as keep some of the energy in. Newspaper was an insulator in my box. There wasn't a ton of it, but it was there. And then, like I said earlier, I had the tube, which I colored black to put my water in. For the water, I took water, put it into a plastic bag, put it into the tube. Pretty simple stuff. I put the poster cap onto the tube and then drilled a hole in it and put my thermometer in there, so I was able to take very quick readings so I didn't interrupt the heating process that much. So I left it out in the sun for 20 minutes per test. I did the 3 tests right in a row just because that's when I had time for it. So I have my data here. The first trial, it was a little bit cloudy out, unfortunately, so I didn't get as good of gains, but I did take the averages, and from these averages I made a graph. It was pretty linear. I was kind of surprised. I thought it would go up more exponentially towards the end, but as we can see, it didn't. So for my calculations, I figured it was easiest to just start with 1 BTU is 1055 joules. The general equation for energy gained is specific heat times mass times change in temperature. So we have our mass. I had 250 milliliters of water in my tube, and the density of water is 1 gram per milliliter, so I had 250 grams. The specific heat of water is 4.184 joules a gram a centimeter, degree Celsius. So we multiply that all out, and we get it's equal to 13.3 kilojoules. So that is 12.59 BTU saved by using our 1 BTU is 1055 joules, and then converting that from the 13.3 kilojoules. So using our 12.59, we find 1 kilowatt hour is 3,412. So we multiply that out. So we find that it took 0.00369 kilowatt hours took that to heat the water as much as we did. 1.09 pounds of coal makes 1 kilowatt hour. We used the conversion factor to find that it was 0.004 pounds of coal that was saved by the solar collector if it had been heating up the same amount of water. 1 kilowatt hour of coal creates 2.2 pounds of CO2. We use this 2.2 times the 0.004 pounds of coal to find that it was saved 0.0089 pounds of CO2 by using the water for heated in my solar oven rather than being on a stovetop. This does not account for the efficiency of my stovetop or anything like that. So for some of my cookers, I used Catherine's cooker. She did a really great job in the construction. She had a ton of very clear pictures, and she actually left it out for a lot longer than I did. I only did 20 minutes, but she did a full 4 hours. And she had a much more gain in the energy than I had in my experiment, which makes sense. But then we had Kristen Wiggins. She really did a great job in the construction of her box. She actually absorbed 63 kilojoules, which is more than 3 times as much as I had in there. And then obviously she did have much greater gains. She had water up to 135 degrees Fahrenheit. And that's it. Thank you.